Hello? Okay, it's working. All right. Good morning, everyone. You have seen me here yesterday. I'm a kind of double agent here because I'm still working for my railroad in Brazil, and I'm a grad student here. So I'm working both projects at the same time. And I'm very glad to be here to show you a little bit of what we've been developing in Brazil. Because as you will see here, we are a very small network, but a very, very complex network with very complex environmental conditions. So we need to be very creative to get some solutions here. And the history that Aldo told here, it's a true history. He stole my opening quote here, but since I was a kid, I like railways since I was a little kid. And I used to take pictures at the train station. And he used to see me there taking pictures. And so instead of, hey, go home, tracks are for trains, not for you, go home. No, he said to me, hey, I can send you some pictures about the new trains we are getting here. And I'm so glad to be here that we are presenting together, showing to the world what we've been doing here. So the rail industry, it is indeed a small industry, but I didn't know even for kids. So take care about them. So what I'm talking about today is one of the test sites that we have for the new ties we are developing. As you can see here, it's a dual gauge track, but dual gauge only one side, only one leg of the turnout. The other one is broad gauge. And here we have broad and meter gauge. And we are testing those ties in this turnout here. It's a very, very bad condition here. It's the access to the Santos port, the biggest port in South America. And there's a lot of trains coming from both directions here, loaded trains, empty trains. So it's a very harsh condition. So why do we need to develop new ties, especially in Brazil? First thing that we don't have good hardwood ties down there. We mainly use softwood ties. Those are eucalyptus. And since we have a bad environment, bad weather, they don't last more than 2 years tops. Something 3 years, but very unusual. So we need to develop new ties to try to increase a little bit the life cycle of them. If we have a low life cycle, we have more maintenance cost. And if you have maintenance cost, especially for wood, we have high environmental impact. So we need to look for solutions for this kind of problem. The first solution we got, it was the steel ties. We start to apply steel ties on empty lines. But in the last year of pandemic, the steel price goes so up that we need to look for another solutions. And then the polymeric ties come in place. So we have a long history of testing polymeric ties. The first ones were installed in 2009, roughly 10 years ago. And here we can see the polymeric ties that were installed. They were prismatic ties. So pretty much the timber ties that we got, but made of polymer. And they have a problem that they were center bound. So they were cracking right in the middle, as you can see here. This tie, you can see like the little bending here. And this is our most used line. It's going uphill. All iron ore trains goes through this line. We have a lot of sharp curves. 10 degrees is the normal there, reverse curves. And we put those ties there, but they start cracking. Mostly here in the center of the tie, and sometimes here close to the fastening systems. Another thing that is usual in Brazil, that we use premium fastening systems, so elastic fastening systems with spring washers in all the line. So that is the standard fastening system there. And here's our network. I'll talk a little bit about the test sites that we got. But as I said, we are a very small network, but a very complex network. We have broad gauge, so bigger than standard gauge. And this corridor here is mainly the iron ore. The mines are up here, the ports are down here. And the loaded trains goes down here for this line. And the unloaded trains goes up here. So it's basically a double track line, but the two tracks are 100 miles apart from each other. So it works very fine. And the test site that Aldo showed, one is here in Bom Jardim. So all loaded trains goes down there. We have a test site with 50 ties from each manufacturer, from each type. So we can test them in a very, very heavy haul environment. The other test site that he showed is here, close to Barra do Piraí. It's I think it's a 10-degree curve that trains are going uphill down there. So it's very, very heavy to test ties there. And we are doing this. And the third test site we got, actually the third, yeah. It's in Santos that I'm talking about. And we have one more that it was the crossover that he showed the drone image. It was installed like a month ago, so we don't have good results on that. We're still collecting data there. But what I'm talking about today is the Santos switch. So like I said, it's a dual gauge switch, and we've been using their timber ties. The rail is a 115 rail, number 10 switches with 0.166. And in Santos, we have a very, very complex network. So we have parts with CTC, we have parts with TWC, so we have spring switches there, we have electric switches, we have everything operating in the same 40-mile section. So it's very, very complicated. And we have 3 railroads coming together, 2 different gauges. And to make it even better, we have a very, very bad ground because it's so close to the sea. The soil there is so messy. Sometimes we need to dump ballast every 6 months because you dump ballast, you surface the tracks, and the ballast is gone because the ground cannot hold this ballast. And we're so close to the sea that when the tide is high and it's raining a lot, the tracks get flooded because you can't drain the water since you are in the level of the sea where the water should flow. So you can imagine how hard it's for a timber tie to survive here in this condition. So we're definitely developing new ties to try to get better results, better life cycle, better maintenance conditions here. And that's the tie that we've been testing. Is a U-shaped tie. In Brazil, we use a lot of steel ties, and steel ties are known to be a U-shaped, so an inverted U-shape actually. And the problem using U-shaped ties is that you need to put ballast in it. That was the question that I was asked. And sometimes we need to manually tamp the gauge, the space between the rails to make sure that the ballast is in there. And then we can come with the tamping machines to do the fine alignment of the tracks. We have 80 units in our super site. That's the P25 here, as they call it. We have more 80 units in the curve in Barra do Piraí. And since it's the steel ties we use shoulders for fast clip systems, but this one we've decided to use timber, to use tie plates. So we need to use those blocks here, and then the screw spikes goes and fix both together. So that's how it's decided to do this, instead of using like a block for a shoulder for different systems. One good thing of this tie is that it's very light. So it's sometimes lighter than a timber tie and very, very lighter than a concrete tie for obvious reasons. And it can be manufactured in any length. So if you have a switch, this tie can be used for every type of switch, of every type of tie in the switch. Even in crossovers, we need to, if we decide to use that design, we have some ties that spans over the 2 tracks. So you can manufacture this tie in any desired length. Yeah, that's it. So here's the installation of the tie. And we need to spend more time flipping them, putting the blocks, and we need to make sure that the blocks are in the correct position for the fastening systems. So we put the blocks, and those ties here, those 2 ties are the ties that go under the switch machine. And we have another problem here, that since the track loses profile and surface very fast, the switch machines start to fail. This is an ODRS switch machine, so it has very, very tight tolerances. And then we need to make sure that the points of the switches are very, very aligned. And when we are using timber ties, the timber ties are gone and then start to lose profile, and then the switch machines start to fail. So we are trying to mitigate those 2 problems here. And those ties, they have these plates here. So they have holes in the whole tie plate, so to say. So we need to use a lot of blocks. And all U-shaped ties, at the end of the day, they are stone ties, right? Because it doesn't matter if it's polymeric tie or steel tie, they are filled with ballast in there. So they behave as a stone tie. And then you need to make sure that the ballast is filled. But sometimes you just need to fill this pocket here, and sometimes you need to fill the whole tie if you're in a plain track. But those 2 ties, they are completely filled with blocks. And here the ties with the switch points mounted, just waiting to be moved to the track. In order to test those ties, we need to decide okay, what is the best method to build the switches? Because it's not like a one-by-one change. I cannot pull the timber tie and put the new tie in and let's go home. We cannot do this. We need to do it right. Because if you're gonna build a new switch, we need to build it right. So how to do this? And the way we decide to do, here we can see this. We mount the switch close to the tracks, and then we cut the track, remove the old switch, and put a new switch in. That is even better because we can dump ballast before, and then make sure that the manual tamping will bring that stone into the middle of the tie. So that's the best method, and that's what we are doing here to test the tie. Here we can see the reverse. It's a Y in Santos Sport. That is one switch here to connect both tracks. And we installed this switch in December last year. I was still in Brazil when we installed this. And so far we haven't seen any gauge defects, no profile defects, no losing fasteners or other components. And switches especially, they have a lot of fastening components that need to hold the ties, the points and frog and a lot of these things. And those get loose very fast if the tie is rotten. The screws and the spikes getting loose, so it's a really problem. And no signs of lateral movement so far. No switch machine failures. That's awesome. The dispatcher loves that. The transportation people loves that. And so far, no visible cracks. And they are performing better than the softwood ties that we've been using down there. So in 4 months, we have better results so far. The idea of testing a new tie is not have like a 25-year-old tie survive in the tracks. But if they are doing better than the other solution that we got, it's awesome. If before that, we need to change ties every year, every 2 years. If it lasts at least 3 years, it's awesome. It pays by itself. So that's our idea here. We don't need to have like a long-lasting time. And that's the mounted switch after the finishing of the work. You may notice that for dual gauge switch, they have a tight gauge here, and it's by design. So it has to be like this to confirm both point of frogs in the same position. So this is normal here. And in this specific switch here, they were attempted manually 3 to 4 times in the day of installation to make sure that the surface was correct and the lining was correct for that switch. So when you install those special ties, and I mean steel, polymeric, or concrete ties, they need to be very, very careful handled in installation. The initial quality for them needs to be very, very careful. And the best work you do there, the longer they last. So we need to make sure that those ties are filled with ballast here. And if I can take any questions, if I cannot answer this, those 2 people here, they definitely can answer for you. And thanks for your attention. Any questions? No, yeah, you are right. That was the first version. The second version has one big block. Is that right, Aldo? Yeah, second version has 1 big block. Actually, 2 big blocks. They are cut in half here, so 1 to each side, instead of those small blocks. The small blocks are used for plane track, just to get the tie plate wide.
I noticed that some of the times you've got the baby followable, you've got a pre-configured hole. Is that for the
Here?
of the ballast? Yeah.
Yes, it's to make sure that the center of the ballast is full with stone. Yeah.
Then every other time that you screw on the tie, you do it in the field.
I don't think we have filled holes here for that. Where's the last? We have only in the middle. Here we don't have it.
Right, so you do that in the field.
Oh, sorry. Yes, we do this in the field. We go with a saw, a special saw, and do the holes in the field. Any other questions? That's a good question, because the concrete ties are so heavy that we cannot easily install them in this condition. And we have a problem that we don't have any tamping machines that are able to lift the heavier concrete ties. So we decided to go on this solution. But for plain track, we use concrete ties from starting this September, I guess. With all those heavy haul tracks, the heavy haul lines here, where the loaded trains goes, we will plan to change all of them to concrete ties the next 10 to 12 years, something like that. Mhm. Those blocks here, right? I think they go a little bit tight, but when the screw tights them, they get closed. Are they glued to the ties or not really? Not glued, just pulled together. Okay. Yeah. And you need to make sure that we are drilling both together in the same spot. You need to drill the tie and the block together. So that can be a trick for labor people used to timber ties, but we can do this at some point. Yes, exactly. Yeah, that's the first version. Yeah. All right, any other questions?
What is the typical tie spacing like in tangent track?
I think for this special tie, we changed the. I have a slide here about that. I think for this type of tie, we have changed to 59 centimeters. I think it would be 22 to 23 inches, something. We have different spacing ties depending on the type of tie. For timber ties, we have more ties. Oh, it's there, the information. For timber ties, we have more ties, so less spacing between them. And for concrete, for steel and composite ties, we have more spacing. So 59 centimeters. But for switches, they're default, right? They're standard. So we cannot really change in the switches. But in plain track, you can do this.
We are studying for MRS, the analysis to free space. That's something that we are already studying right now.
Yeah. All right. So thank you.